All right, today we're diving into something truly mind-bending. We're talking about a visitor from deep space that's making us question everything we thought we know about the universe. This is the story of a comet that, by all accounts, just shouldn't be possible. 3I/Atlas.
So let me just ask you this. What would you think if a comet's tail pointed the wrong way? I mean, completely backward. Instead of streaming away from the sun like every comet we've ever seen, it's pointing right at it. Sounds impossible, right? Well, that's exactly what astronomers spotted.
Okay, so here's the rule book. For hundreds of years, it's been a simple fact. The sun's solar wind pushes a comet's tail away from it. It's just basic physics. But then along comes 3I/Atlas, and it just rips that page right out. It's got this bright, steady tail pointing straight back at the sun. That means the push we always see is somehow being beaten by some mysterious, unknown pull.
And that's what brings us to our first big point. You really have to stop thinking of 3I/Atlas as just another chunk of ice and rock. No, this thing is like the main character in a huge cosmic mystery, and its first move was to just shatter one of the most basic rules we have.
So, the story kicks off back in 2025. This visitor from another star system swings by our sun, and as it gets closer, it just starts doing things that, well, our physics books said couldn't happen. And that crazy sunward tail? It wasn't just some weird glitch or a one-off thing. Nope. It was stable. It was real. And folks, it was only the beginning. Because you see, that impossible tail wasn't the only weird thing. Not by a long shot. It was more like the first domino to fall in a whole series of strange, interconnected puzzles. With every new look they took, the mystery just got deeper and weirder. And this really lays it all out. First, you've got the sunward tail. Check. Then, the comet starts to glow this incredible emerald green. Now, you might think, okay, green comets, we've seen those. But here's the twist. Scientists pointed their instruments at it, looking for the usual suspect for that green color, a chemical called diatomic carbon, or C2. And guess what? There was zero. None. And if that wasn't enough, the final clue was just bizarre. The light coming off it had this unique signature, something called extreme negative polarization, that we have literally never seen from any object before. So, you can imagine the head-scratching going on, right? How can one single object break so many rules all at once? A backward tail, a mystery green glow, a one-of-a-kind light signature. Are these just random, separate problems? Or is there one single, deeper explanation that connects everything? And that question is what led to a really radical, out-of-the-box idea. What if we've been looking at this all wrong? What if these aren't four different puzzles, but four symptoms of the same incredible phenomenon? Enter the magneto-metallic attraction hypothesis, or MMA for short. And the core idea is as simple as it is wild. What if 3I/Atlas isn't your typical dirty snowball of a comet? What if it's actually a huge nickel-rich object, and its bizarre behavior has nothing to do with the solar wind and everything to do with a powerful magnetic battle with our own sun? It really breaks down into three pretty neat steps. First, it's all about what the comet is made of. It has to be packed with ferromagnetic nickel. Step 2, as the comet sheds this nickel dust, the super hot environment around it basically turns that dust into a stream of tiny aligned magnets. And for step 3, that stream of little magnets gets pulled on by the sun's powerful magnetic field. Now, here's the key part that makes it all work. The sun's magnetic field isn't this nice, neat bubble. It's actually a chaotic mess of powerful currents, which the theory calls magnetic rivers. And the idea is, if you fly into one of these rivers, the magnetic pull is so incredibly strong that it can completely overwhelm the push of the solar wind. And this comet, it just happened to find one. Okay, so now we have this wild new theory, the MMA hypothesis. The big question is, can it solve all those weird problems we saw earlier? Let's find out, because this is where it all starts to click into place. All right, first up, the big one. The whole reason we're here. Why the heck is the tail pointing toward the sun? And here's the answer, laid out perfectly. Normally, the solar wind always wins. It pushes everything away. But with the MMA hypothesis, you've got a new player on the field. When the comet enters that magnetic river, the magnetic pull on its nickel dust is just stronger than the solar wind's push. It's a cosmic tug of war, and magnetism wins. The result? A tail that gets yanked straight toward the sun.
Okay, so that's mystery number one solved. But what about that green glow? Remember, we saw the color, but the chemical that's supposed to make it, C2, just wasn't there. So, how on earth does magnetism explain a color? Well, this is my favorite part. The old theory says you need C2, but our eyes and our instruments tell us it's not there. The MMA theory's answer is just beautiful. The glow isn't a chemical reaction at all. It's a physical one. Those nickel particles, caught in the magnetic river, are getting zapped by solar energy, and they light up, exactly like how the northern lights, the aurora borealis, are created in our own atmosphere. It's basically a cometary aurora. So, the theory beautifully explains the tail and the color. But what really sealed the deal, what took this from being just a cool idea to a serious contender, was that weird light signature we talked about. You see, a really good scientific theory doesn't just explain stuff we've already seen. It makes a bold prediction about something we haven't seen yet. And the MMA hypothesis did just that. It predicted that if this tail was really made of magnetically aligned dust, then light should bounce off it in a very specific, very strange way. And bingo, that's exactly what they found. The comet showed this extreme negative polarization. Now that sounds super technical, I know, but what it boils down to is this. The way light was scattering proved that the dust particles weren't just a random cloud. They were organized. They were lined up in a structured way. Precisely what you'd get if they were tiny magnets being held in formation by a powerful magnetic field. This was the smoking gun. But wait, there's one more piece of the puzzle, and it's a bit of a twist. As the comet was heading away from the sun, astronomers noticed something strange. It was slowing down way more than it should have. Think about it. As it's leaving, the solar wind should be giving it a little push from behind, like a tailwind, while gravity is gently pulling it back. But the comet was hitting the brakes harder than just gravity could account for. And the MA theory gives us the answer. That magnetic pole wasn't just grabbing the tail, it was grabbing the entire comet, acting like a giant invisible brake. And all of this really brings home this fantastic quote from Alexander E. Campaign, the author of the theory. This whole journey, this whole mystery, it wasn't about some simple illusion or a trick of the light. It was about having the imagination to look at a whole bunch of impossible things and realize, hey, maybe these aren't impossible. Maybe they're pointing to a whole new law of physics. So there you have it. 3I/Atlas has shown us that a comet can have a magnetic tail, create its own aurora, and be slowed down by invisible forces. It completely rewrites the book. And that just leaves us with one final thrilling question. What other rules of the universe are out there just waiting to be broken?